The AVND machine series shown here is an advanced version of the proven AVN technology. Thanks to a pressure chamber, this machine can switch from slurry to mix shield mode during ongoing operations, and thus open up a greater range of heterogeneous soils. The following animation shows the use of an AVND machine. The launch shaft is set up on the site. This can be achieved by means of sheet pile walls, slurry walls, or bore piles. The TBM is delivered on site in modules. The container with the control cabin, electrical equipment, and hydraulic power unit for the jacking station is positioned next to the launch shaft, so that the machine operator can see the jacking station. The product pipes are delivered by truck, sorted, and stored on a firm subsoil. For faster pipeline installation, the pipes are prepared with brackets to accommodate the slurry and feed line. A separation plant and several sedimentation tanks, as well as a bentonite mixer, are placed in the vicinity of the launch shaft. The push rails for the main jacking station are assembled in the tunnel axis. These push rails serve to exactly position and guide the machine and jacking pipes. A concrete block is cast on the back of the shaft, which transfers the force of the main jacking station to the shaft wall. A startup seal is needed to seal the shaft between the jacking pipe and the ground. With sufficiently large shafts, the startup process is simplified considerably. In this case, the first two modules, tunnel boring machine and machine pipe, can be fully set up inside the launch shaft. To operate the AVN, a closed slurry circuit is necessary. A slurry pump is installed in the launch shaft, and the feed pump is installed at the separation plant. The system is connected to the tunnel boring machine with slurry lines and hoses. The system is filled with water or bentonite, a mixture of water and clay powder. Once the tunneling system has been fully connected to the hydraulic and electrical supply, it can tunnel through the lean mixed concrete block in front of the startup seal. The thrust cylinders are extended and push the TBM into the startup seal. Now, the slurry circuit is put into operation. The rotating cutting wheel pierces the lean mixed concrete block. The excavated material is conveyed to the separation plant. Now, the next machine module can be installed. After another stroke, the last module is installed. After each stroke, the quick-release fasteners of the connecting hoses are released to make room for the next pipe installation. The tunneling pipes feature a pressure-resistant design, enabling them to safely take up the high load exerted by the tunneling forces, jack friction, water pressure, and soil loads. Each tunneling pipe features a circumferential rubber seal on the front, while a steel collar is integrated on the end of the tunneling pipe. When the tunneling pipes are pushed into each other, a watertight yet flexible connection is achieved. Now, regular tunneling begins. After every stroke, a new product pipe is installed. When the main jacking station extends its cylinders, it pushes the entire pipeline and tunneling system forward. The force of the presses is transferred to the rotating cutting wheel, and the cutting tools on the cutting wheel remove the soil from the tunnel face during tunneling. The cutting wheel is fitted with disc cutters and cutting knives. The type and number of tools are determined by the anticipated geology. Behind the cutting wheel is the crusher chamber. During operation, the whole of the chamber is flooded with support fluid. The cladded spokes of the cutting wheel act as a grinder, working on the principle of a coffee grinder. The larger pieces of soil are crushed so they fit through the openings of the crusher cone and can be carried away. Together with the support fluid, the excavated soil is suctioned by the pump and pumped through the slurry line to the launch shaft. Another pump transports the material to the surface to the separation plant. There, a multi-stage separation process separates and removes the excavated material from the support fluid, and the clean suspension is fed back to the machine again. Through a nozzle system in the shield, the liquid is returned to the excavation chamber. A closed slurry circuit is thus created, resulting in a continuous advance. The AVND machine concept allows the machine to switch at any time to one of three possible modes of operation: slurry mode, mixed shield mode, and hard rock mode, and thus adapt to the geology. When tunneling in homogeneous, fine-grained soils, the machine works in slurry mode. In this case, only the excavation chamber is completely filled with support fluid. The support fluid, usually water, is piped to the 6 medium-pressure nozzles. The vast narrowing of the nozzle creates a powerful jet which, in cohesive soils in particular, cleans the cutting wheel of clogging and allows high advance rates. The support of the tunnel face is achieved by the force equilibrium of natural soil and groundwater pressure on the one side and the counterpressure of the support fluid in the excavation chamber on the other. When tunneling through less cohesive, coarse-grained soils, the machine is switched to mixed shield mode. Behind the excavation chamber is the pressure chamber, which is empty in slurry mode. In mixed shield mode, this is flooded with bentonite and pressurized with a compressed air cushion. To this end, the compressed air supply is activated, the support fluid enriched with bentonite, and the nozzle configuration switched. Instead of the medium-pressure nozzles, now the annulus nozzles are activated, which direct the bentonite suspension in behind the crusher zone. The annulus nozzles are centered on the intake and ensure that flow turbulences in the excavation chamber are kept well down. After the communicating pipe is opened, pressure equalization takes place between the tunnel face, the excavation chamber, and the pressure chamber. Any pressure variations at the tunnel face are now balanced by the compressible compressed air cushion with its damping effect. The slight overpressure in the pressure chamber set as a default on the compressed air control system ensures that the bentonite can penetrate into the tunnel face and forms a filter cake. This supports the tunnel face and ensures safe tunneling without settlement or heave. When tunneling in rock formations, the invert nozzle is activated. This flushes away fine particles that settle in the invert area during tunneling. This keeps the annular gap around the machine clear and the overcut is maintained. In this case, only the excavation chamber is completely filled with support fluid. The pressure chamber is not in operation. Additionally, support fluid is also supplied via the medium pressure nozzle. To minimize pipeline friction in the ground, the outer side of the pipes is lubricated with bentonite. Bentonite lubricating stations for distributing the lubricant are installed consistently at brief intervals. The bentonite is injected into the annular gap between pipe jacket and ground and spread over the pipe surface. This ensures that friction is kept substantially down.